So, today we're going to have a look at tangents to circles, and by the end of this lesson I'm hoping that you're going to be able to describe what a tangent is, describe the relationship between a tangent and the radius, and then apply these facts and problems by creating right angle triangles. So, a couple of things that we should know already. The angle in a semicircle is always a right angle. Okay, so if I draw a line from A up to the circumference and then down to point B, I always get a right angled triangle forming as well, with the diameter as its base. So I've just covered the first 2 points there. As you can see, AB is the diameter, and again we can apply these facts to problems involving angles, Pythagoras and trig. So on to the main point about today. The tangent is a line which touches a circle at only 1 point. So what I'm going to do is I'm just going to draw myself a tangent in, only touching at 1 point, and I'll do another one over here. And the second point says that the radius of a circle always meets tangent at right angles, and we're going to use that fact today. So I'm just going to draw in a radius just down in the middle, into the centre there, and I'm going to do the same here, just down into the centre, and I'll just mark in those right angles as well. So we've got a right angle here, and then here, and here. So we're going to apply this into a couple of examples, and example 1 is a triangle. Now, using the property we've just talked about, this angle here must be a right angle, and then angles in a triangle always add up to 180 degrees. So to find x, I'm going to do x equals 180, take away 90, take away 31, and I'm going to get that x is equal to 59 degrees. So x is equal to 59 degrees. Okay, example 2, we've got a right angle triangle, again using that same property, and we're trying to find the missing side, and we've got 2 other sides there. We're going to be using Pythagoras now. X is the hypotenuse, so we've got x squared equals 12 squared plus 20 squared. X squared is 144 plus 400, so x squared is 544. To find x, I'm going to take the square root, so 544, take a square root, and to 1 decimal place, x is equal to 23.3 millimetres. Okay, so the last kind of point about today is something called the tangent kite. Now, what we have here is a circle with 2 tangents, tangent AP and tangent BP. Now, OA and OB are both radii, and what we're going to have a look at is the fact that we can see this kite being formed. Obviously, these 2 are equal because of the radius being the same size of, obviously, and then we've got a line of symmetry across the middle. That means AP and BP are both the same size, and what we know is the radius meets a right angle, so we can add these in here. Now, I'm just going to get a different colour, and I'm going to shade in these 2 angles that are remaining. Now, because the kite is a quadrilateral, we know that its angles add up to 360 degrees, and we know the angle OAP, and OBP are right angles. That must mean the angle AOB plus angle APB is equal to 180 degrees. So we're going to use that fact. So this fact here, I'll just put it in a bubble. We're going to use that fact in problems, another problem as well today. So on to the last kind of learning slide today. We're going to find the size of angle AOB. So angle AOB, this one in here. So I'm going to just use that property that we know that OAP and OBP are right angles. So all I'm going to do is to find angle AOB, I'm just going to do 180, take away 42, and that is going to give me 138 degrees. So angle AOB is just 138 degrees. So on to the last slide, a couple of problems for you to try. One using trigonometry, you're going to use the same application as you did with Pythagoras, and then working out angle x with the kite problem there as well.